As the question says, a bullet of mass 10 grams moving horizontally at a speed of 50 root 7 strikes a block of mass 490 grams kept on a frictionless track as shown in the figure. The bullet remains inside the block and the system proceeds towards the semicircular track of radius 0.2 meters. Where will the block strike the horizontal path after leaving the semicircular track? Now what's happening in this question is that this bullet will come, it will go inside this block, and due to that momentum this block will start moving. It will go up this incline. If it is able to reach the top, then it will come with the horizontal velocity and will do the projectile motion. But there is one more possibility, that it may not reach the top. It may stop somewhere in between, like here, and then it will drop like this. We need to find out the total distance that will be covered by that system. So let me draw a bit clear diagram in which I suppose, just to take the normal, that is the general case, that this block stops at an angle of theta. Let this be theta, right? And let me assume that this, first of all, let me have the momentum conservation over here, because there is no external force to the system of bullet and this block. So I can write it as m1v1 plus m2v2 will be equal to m1 plus m2, because bullet remains inside the block, into v. m1 is 10 grams, so 10 by 1000. v1 being 50 root 7 plus m2 being 490 grams into v2, that was 0. m1 plus m2 being 500 grams, this being this, and the velocity v which we need to find out. So this gives us the velocity v to be root 7. That is, this system actually, once this bullet hits it, moves with a velocity of root 7 to the left. Now it will go and proceed to this semicircular path, and we assume that it reaches this part, or let me mark this position as A. Now at this position A, there will be a centrifugal force of mVa square by r, which will be equal to, because this is theta, so mg sine theta, which gives us the value of Va to be gr sine theta. Now let us mark it as equation number 1. Now we are employing the work energy theorem between this position A and the initial position. Now what is the final velocity? This is half mVa square. The initial being half mv naught square, the v naught being this root 7. This equals to total work done. So work done by the gravitational force being negative, and the negative work done being minus mg into height. Now what is height? The height is this one, that is the radius 0.2 plus this one. If this is r, then this must be r sine theta. So this height becomes 0.2 plus 0.2 sine theta. Now we are having the value of masses over here, values of Va, Vb as well as mg. Only sine theta is unknown over here. This gives us the value of sine theta to be half, which implies that theta is basically 30 degrees. So at 30 degrees, this will leave the contact with this semicircular part. Now after that, this will be definitely a projectile motion. Now let me first find out the time period of this fall. That is, it takes to come to the ground level. That time comes out to be under root 2h by g, which comes out to be 0.247 seconds. And what will be the distance? I'm counting the distance from this part only, that is the horizontal distance, this one. Okay, so that distance will be v cos theta, rather I should say this will be va cos theta into time, that is t. So this gives us under root gr sin theta into t cos theta, giving us the value of 0.196 meters. Now friends, this is the distance this system actually covered from this point, means this was the projectile range, but we need to find the total distance. The total distance means we need to add this distance also. Now what is this distance? This whole is r, this is r cos theta from this triangle, so this is r minus r cos theta. So we need to add this distance small d to this part s in order to get the total distance. Let that total distance be capital D, so that is s plus small d. What is s? It is 0.196. And what is d? This is 0.2 minus 0.2 cos 30 degrees, giving us the total distance of 0.22 meters.